So I actually asked to answer why all proteins are polypeptides, but not all polypeptides are proteins. Let's look at the full questions. All right. So the full question was like, okay, all proteins are polypeptides, but not all polypeptides are proteins. So discuss this briefly. So can I say, all right. So you see that polypeptides means that okay, there are many peptide bonds. So yes, many proteins are this thing contained of many amino acids forming many peptide bonds. Many proteins, okay, many amino acids forming many peptide bonds, but not all amino acids coming together will make a protein. And let's see why. So we say that proteins and polypeptides are closely related, but they are not the same. Okay. Now looking at polypeptides now, you see this is polypeptide. A protein can break into polypeptide and amino acid. Do you get? So let's have it for polypeptides. Polypeptides are what? Chains of amino acids which are linked by what? Peptide bonds. Okay? So they can range from a few to several hundreds of amino acids linked in a length or in a chain. What are the functions? Polypeptides they serve various roles, including serving as intermediate products in protein synthesis, or they actually serve as a part of larger protein complexes. Okay, so for protein now, what is the structure of protein? We said that proteins are one or more polypeptide chains folded in a specific three-dimensional structure. Do you understand? Polypeptides could just be long chains, just long chains. They are not folded in any specific three-dimensional structure. You get? And this three-dimensional structure that these proteins are folded into is actually essential or crucial for their function. All right. So they often have what complex secondary, that structures of proteins. We have primary proteins, secondary proteins, tertiary proteins, quaternary proteins contained of subunits. All right. So it's actually polypeptides that become specialized into proteins, but not every polypeptide is specialized into proteins. So it's just like specialized polypeptides are the ones we call proteins. You get? So proteins have different functions. So proteins are functional molecules that perform a vast array of biological functions, including catalysis, that's performed by enzymes, structural support, that's collagen, transport, like hemoglobin can transport oxygen, myoglobin can also transport oxygen. Then regulatory functions that can be done by hormones. Okay, so you can see that what proteins are actually specialized polypeptides. Why not all polypeptides are specialized? Right? So that's why they say all proteins are polypeptides, but not all polypeptides are proteins. So for a polypeptide to be a protein, it must be folded into what? That three-dimensional um, structure. You get it? So now, what is the key distinction between proteins and other polypeptides? All proteins are polypeptides with a functional and stable three-dimensional structure. But not all polypeptides have achieved the necessary structure that is needed for them to become proteins. You get? So in essence, why polypeptides form the basis of proteins, they must be folded in that specific structure and they must be able to interact with other polypeptides to become functional proteins. Okay? So this folding and functionality is what differentiates proteins from other simple polypeptides that we know. Right? So that's it on the basis of saying why is it that all proteins are polypeptides, but not all polypeptides are proteins? Answering that question.